third lecture in the course about open source best practices, where we discuss what you as programmers should be doing in your open source projects in order to get better results, in order to be more popular, in order to be more successful, in order to be more effective, and in the end, as we discussed before, you may achieve better results in your business, in your career. If you will be popular in open source, then you will be more visible and more valuable for your potential employer, because they will understand that you know how to deal with other programmers, you know how to organize your work on your own, you know how to make contributions to repositories where your work is not as much appreciated as it might be in a proprietary repository. So you are more prepared for challenges. This is basically what I consider open source when somebody comes to me with a CV, with a profile information about themselves as a programmer, and I see that there is some open source contribution, there is some track record about projects which were done, about projects which were participated in. I know that this person, this programmer, actually was able to go through a lot of challenges, a lot of unfriendly situations, like we discussed on the first lecture, where we talked about the toxicity of open source domain, about the problems with self-representation, all of that. And if I see that that person, that programmer, managed to do all of that, that there is a profile of projects, a profile of contribution to other repositories, to other projects, then I know that that person can do a lot of things which people who didn't do that cannot do. So I suggest you keep it in mind when you decide whether to work in some open source activity, or you decide not to do that. And aside from that, everything we discuss on these lectures may be applicable to your proprietary projects, to the projects which you will be doing inside a company, which will not be open source. In these projects, the same principles can be applied, the same mechanisms of contribution, the same rules of communication with other programmers, the same principles of reviewing changes, accepting changes, making bugs, reporting bugs. All of that is very similar in the proprietary repository, similar to open source domain. Today we discuss making changes, so basically making pull requests, or in some storage systems, unlike GitHub, these things may be called merge requests, or just changes, or maybe patches. No matter how you call it, the idea is the same. There is a repository, you are a programmer, you make some changes, and then you want to put these changes into that repository. So your job is to convince the people who work there that your changes deserve to be merged. And I can assure you that this is not going to be easy. Take a look at the numbers which were collected just, about 10 years ago, but still I believe the numbers are quite relevant to my personal experience, for example, to what I see in this in open source repositories, and to what you will see when you join this game. Only one out of three, only 30% of the patches, in this case, they're talking about patches. Now we can talk about pull requests. So only 30% of these changes, they are merged into Linux release, into the master branch, or call it the way you want. In case of Linux, it may be something else, but that's the overall principle, is that your changes will be rejected in most cases. And if they will be accepted, then it will take from 3 to 6 months to get them accepted. And we're talking about patches which are written by people who know mostly what they're doing, because it's not so easy to commit a patch to Linux repository, because the complexity of this system is quite high. You most probably will contribute to smaller repositories with the complexity much lower than Linux, So maybe your acceptance rate will be higher or maybe not. I'm not sure, but be prepared for rejections. And I think that you have to understand that whether your changes are accepted or not, it's your personal responsibility. So don't be offended, don't be frustrated by the fact that your changes are not welcome, that they don't need them, they don't want them, they don't review them, they reject them, they criticize them, they don't like you and your changes. It's going to happen. And your job is to push it through. Your job is to insist. Your job is to make it happen, to close this transaction. You are the leader of this transaction and you have to close it. If you don't do that, don't blame the repository. Blame yourself, always, in this case, in case of this failure. If you cannot push your changes to the repository, it's only your fault. If they have strange rules, if they have some suspicious mechanisms of validating your changes, if they have an idiot for an architect, it doesn't matter. You have to get through. You have to go through all the barriers and make sure the transaction is closed. I see a situation where people make pull requests to my repositories. I push them back. I suggest some additional changes. I suggest to create a unit test, which people very often don't make. I suggest to check the continuous integration situation with this pull request because people sometimes don't pay attention. I suggest changes and they just walk away. They walk away because they're lazy, because they don't have time, because they lose interest, because many reasons. But in the end, they lose. In most cases, they lose because they invested time already into making the pull request. They already spent some energy to make that, and then they just don't close the transaction. I suspect that some of them believe that I lose in this case, the maintainer of the repository. Maybe it's true to some extent, because definitely in most cases there is something interesting in this pull request. So I would benefit from getting that code to my repository. But if the changes are interesting, if the pull request contains something valuable, then I would just take that data from there, take that code from there and put it into my repository and just reject the pull request if the author of the pull request doesn't finish it. And it happens very often. They just open the pull request, they submit the code, they don't complete it, they don't make it final, they don't make it pass all the unit tests and all the verification checks, and they just walk away. I wait for a week, for 2 weeks, for 3 weeks, for a few months, then I see that the interest is lost, then I just close this pull request, I just delete it, so there is no check mark for that person. That person cannot be proud anymore and cannot say anywhere that there was a contribution to this repository. So there is no value for him or for her, for that person, no value achieved. But I get the value because if the code is interesting, I just put it into my repository and that's it. So to summarize, it's your job to close it. And now I will give you a number of recommendations which you can use like I did on previous lectures, one after another. If you listen to me, I think you will be more effective. Recommendation number 1, make small pull requests. The smaller the pull request you make, the higher the chances that it will be merged. Long pull requests are a trouble for everybody, for the person who makes them, for the people who review them, for the repository, for the traceability of the changes, for many reasons. First of all, for you, when you make long pull requests, which contain, let's say, 100 lines of code, it's already a large pull request in my world. 100 lines of code. You invest quite a lot of time to make this code, to write that code. Then you submit it to, let's say, to me. And to review your pull request, to make a decision that your code is good, I need to take a huge responsibility. I need to take a huge risk because the change is big. It's 100 lines of code. So I understand that as soon as I accept your pull request, as soon as I merge it into the repository, you will just walk away because it's open source. So you will just disappear as a contributor. In most cases, this is what happens. People just make pull requests and they just disappear. Sometimes some of them, they stay in the repository, so it's possible to connect with them somehow and ask them to improve something. But most of the people, they just walk away. So for me, it's just yes or no. It's just go or no go situation. If I say go, if I take your code, it becomes my code. Now I'm responsible for this code. And if it's 100 lines, then I need to fall in love, let's put it this way, fall in love with 100 lines of code, which is quite difficult to do if it's not my code. If you submit 10 lines of code to me, it's easier for me to take this risk. It's easier to fall in love with this text, with this code that you wrote. It's easier to accept it and accept the fact that now it's my code, not yours anymore. So your code will be merged faster. Sometimes people say that it's not true, that it's better to make a large pull request and put all the features in there, all the functionality, everything that you had the chance to implement, because for the reviewers, it will be easier to take a look at the full picture, to take a look at the entire feature implemented there, instead of making micro changes. Because when I say make small pull requests, I don't mean make small contribution. I mean make many small requests instead of making a large one. So instead of making one which is 100 lines of code, I suggest making 5 of them with 20 lines of code in each of them. It may look like a longer story for you because it will take 5 steps. It will take 5 code reviews. It will take 5 times the architect of the project will click the button. But overall, the risk is lower, the acceptance rate will be higher, and you will make the people on the repository way more happy. Because, like I said, because it will be easier for them to review your code, in my understanding, even though there is an opinion that it's not true. But let's take a look at what researchers say about that. One story, 2015, they say that they found that the more files stay in the pull request, the lower the proportion of comments in the code review that will be of value to the author of the change. So basically, the more files you put in there, the more files you change, the less comments you're gonna get from the reviewers. And that's just logical. What is said here, we don't need, in my opinion, to do a research for that. It's just clear. Because if I'm the reviewer, I'm just lazy to do that. It's harder for me to go through many files and to put the comments there. I will just look at it as a bigger picture, as a large change, which I will either reject as a whole. I will just find something which will be the reason to reject. So when I look at the larger piece of code, I try to look for a reason to reject, instead of actually thinking what kind of valuable comment I can provide. What exactly I would suggest you to change. When there are 5 lines of code, it's interesting for me. It becomes way more interesting for me to actually to teach you, maybe to treat this situation, to understand this situation as a teacher-student position. It doesn't matter who is there, who is on the other side of the pull request. It could be a person older than me and way smarter. It doesn't matter. I take this situation as a teacher-student's disposition. You submit to me, so my job is to review. My job is to criticize. My job is to say you're right or you're wrong. And I don't want to just say you're wrong. I want to teach you. I want to help you make better contribution. When the code is small, it's way more interesting for me to do that. Another story from Google. They are saying that there is a correlation between change size, which is the size of a pull request, and review quality. And this correlation is acknowledged by Google. So they're saying that the larger the change, the lower the quality of the review. And they say we strongly encourage to make small incremental changes. with the exception of large deletions and automated refactoring. This I can understand. Of course, if we have 1,000 files in the repository and you want to change something similar in each file, then you make a large pull request, but then it's obvious that your changes are identical, similar. You're just doing repetitive changes, and it's easy to review them because I just need to review one of them, and the rest of them I can just trust. But otherwise, Google recommends that, and I join this recommendation that you have to make smaller pull requests. That's rule number one. When you see that you are making something larger, then it's an immediate red signal for you. It's a red line, stop there and break it into pieces. And you can always do that. In my opinion, 10 lines of code, that's 10 from up, maybe up to 20 lines. This is the maximum size of a pull request. If you go over 100, that's a red zone. If you go over 1,000, just forget it. I would suggest to immediately reject such a pull request. On the next lecture, we're going to discuss how to review pull requests. And I will recommend you there that when you see the pull request, which is larger than 100 lines of code, just reject it. Don't review, because we know that the quality of your review will be low. You will not be able to do a professional review, a detailed review, because we know it's difficult. My second recommendation, don't group your changes. And by the way, sorry, let me roll back. So as in previous lectures, I make you like references to blog posts, which I wrote some time ago. If you're interested, you can go into deeper study of there, and these blog posts, they basically formulate the same thoughts I'm giving you here, but with more details and maybe code examples. I'm not showing you as much code examples on this set of lectures, but I encourage you to take a look at these blog posts, and there you can find code samples. So recommendation number 2 is don't group your changes inside one pull request. If you need to add a feature and then you need to add another feature to your code base, people very often, they just do it together in one pull request because it's faster. And I see it every day. They just submit a pull request, and in the pull request description, they say, I fixed this feature and I fixed that bug and I introduced that changes, and take a look, that's all coming in together. That's wrong. We don't do that. Why? Aside from the situation which we just discussed, aside from being larger, and your changes will be larger if you group them together, but let's say you have 3 micro changes. Let's say for one bug fix, you need to make a change in 1 line of code. For another bug fix, you need to change 2 lines of code. And then for another one, you need to change 5 lines of code. 1, 2, and 5. So it's 8 lines in total. It seems to be like a small pull request, right? So what's the point of making 3 pull requests instead of making 1 and putting these 8 lines of code together? The reason number 1 why you shouldn't do that is that if your changes will be rejected or will be stalled, so they're going to stay longer in the review phase, the team will just review and review and review, and it will take time. Then 3 fixes are blocked. You were working on 3 tickets, on 3 bug reports, or maybe 3 feature requests, and you decided to fix them all 3 at once. You submitted them 3 together, and they're blocked because you made some mistake in one of them. So you blocked 3 of them, and that means that the delivery, the coding is not moving forward. So you're just staying, and it happens very often. And then it leads to frustration on your side, because you will be frustrated 3 times more than if you would be frustrated just once. So you block yourself in this case. And imagine every time you work with the pull requests, imagine that you are being paid for each pull request which is merged. Just put this mindset into your head when you work with pull requests. Imagine that every time your pull request is merged, you get a certain amount of money. Just for a pull request, it doesn't matter how big it is. Is it big or is it small? It's just one pull request, the same amount of money goes to your bank account. So obviously it will be more interesting for you to make 3 pull requests instead of 1, just for this reason, for the financial motivation. That's just a recommendation which will help you to understand why you need to make more pull requests. And for the repository, it's better because you increase manageability of yourself. And you, being a programmer, well, not in open source repositories. Imagine we're talking about proprietary repositories where there is a manager, somebody who is telling you what to do, somebody who is expecting these bugs to be fixed. And then this manager expects 1 fix, another fix, another fix, 3 fixes. And of course, the manager doesn't want to wait for 3 of them together. It's better to get at least 2 or at least 1. But when you take 3 of them together, you kind of block them all 3, and then we should expect either all of them getting in or none of them. You should help the management of the repository to decompose the work, the entire work, and keep this decomposition under control. When you join changes, you compose instead of decomposing, and then you lower the manageability of the repository. And of course, let's say it's an open source territory and you join the project and you see 3 bugs there and you say, I'm going to fix them all 3. Okay, everybody will wait, so nobody's going to touch them because we know you're working on them. But you block them all 3 and you don't merge because you made a mistake. People make mistakes. You can also make a mistake. So 3 of them are blocked. Nobody can touch them. We wait for you and you don't deliver. That's not good. So don't group. Instead, split them. And this is what, again, the research is saying. And again, the research is coming from Google. So they're saying that the first part is less important, the second is more important. The general advice is to split change requests for easier and quicker reviews when possible. That's exactly what I was just telling you. Google says the same. They suggest to split. They, in the paper, of course, explain why, but I think I gave you enough explanation. It's valuable, it's reasonable for many purposes to split your changes. So when you're coming with a large pull request in which you're saying that you managed to fix 5 problems at the same time, what do we know about you? That you're an immature developer, that you just don't know what you're doing. That not that you're so productive and you want to show how productive you are. Instead, we see that you just don't understand the dynamics of software engineering. It will be okay, it will be more welcome, it will be more respected. You will be way more respected for smaller changes. Don't be scared about pull requests with just a few lines of code changed. These pull requests are totally okay. Nobody's gonna blame you for making small pull requests. They will definitely blame you for making large ones, but never for small ones. No matter how small they are. Even if you make a change, it's just 1 line of code. That's perfectly all right. It's not a problem for us to click the merge button to merge your 1-line change. But that's a bigger problem if you submit 500 lines of code. That you make the people unhappy, angry, uncomfortable because you ask them to review too much. And also, when you merge them all together, all these changes, when you join them together, let's say you're coming with 3 bugs in the same pull request, you kind of put the message in there like, please merge them all together. And even if you see the problem in the bug fix number 4, there's more changes coming there which are valuable. So please merge them all together. And I have to close my eyes on the defects which you made, on the imperfection which is staying inside your changes, inside your pull request. I have to accept all together. And as we're going to discuss on the next lecture, again, about reviewing pull requests, we will see that programmers who wait for the changes in open source, they understand that this connection between the person who makes the changes and us who review the changes is very thin, it's very unstable. So we don't know where you are and we don't know whether you will continue working with the pull request if we tell you that there are problems. in the pull request. Most probably you're going to just walk away. Like I said, people just drop off this conversation, drop off this transaction. They lose interest. And we must be super careful. So when you bring us a lot of changes in one package, you put us in a very difficult, morally difficult situation. On one side, we do want your changes because there are many interesting things inside, because you fixed 5 bugs at the same time. But also, we don't want to get your changes on board because they're too big, and most definitely there are imperfection there. So what do I do? How can I resolve this moral dilemma? So what should I reject? Should I tell you, no, please continue working and make it perfect? Or I should just make a compromise and accept your stuff, and then what? Then I need to jeopardize the quality of the repository. I need to lower my quality bar. I don't want to do that. And I don't want to lose you at the same time. So I have two. What do I choose? To keep you happy, to keep you interested, to keep you motivated, to keep you engaged, or I keep my repository of high quality. Don't put me into this dilemma. Don't put me into this choice. Don't make me make this choice. Recommendation number 3, insist on code reviews and merges politely. This is what we started from today. I just make it more formal now. It's your job to insist. You have to push. You have to convince me as a maintainer of the repository that your changes are valuable, that your changes are good enough, that your changes do not compromise the quality of my repository. All of this, it's your job. You insist. And because it's your job, don't be scared on insisting. So you submit the pull request and don't just expect that the team or the maintainer of the repository will just happily jump in and say, wow, I've been waiting for you for so long. Thanks for coming in. I'm going to merge it right now. It's not going to happen. Most probably they're not going to pay attention to your pull request for months. This is what will happen in open source repositories in most cases. Unless you're coming with something very interesting, with something that they were waiting for, and this repository is under active development. Then yes, they can pay attention to you the same day. But usually your pull request will be just stay in the pipeline for weeks, for months. Nobody gonna pay attention. And it's not their fault, it's not their mistake, it's not that they are bad, it's just you are not doing your job, you're not insisting. So when you submit a pull request, find out who is the person responsible for reviewing the pull requests. Maybe you can check previous pull requests and you can see who is replying to them, who is clicking the button, who is clicking the merge button. So find out who is this guy. And then in your pull request, when you submit it, just write a message right after the pull request. So you submit the pull request, you have it, and then you post a message under the pull request and say, hey, John, whatever, 1, 2, 3, please pay attention. I hope I didn't break anything. I would like your opinion. I would like this stuff to be merged. And probably it would be better if you explain why you need this merge. You can say, because I'm using your library, I'm using your software, I'm using your tool or your framework. And that's why without this change, I cannot continue, I cannot move forward. So this change is mandatory for me. It's critically important. It's mission critical. So exaggerate, like we discussed with the bug reporting, the same here. Make it look like a tragedy if it's not merged. Make it look like a super valuable contribution if it gets merged. But that's your job to do that. Nobody's gonna do it for you. Insist, but do it politely. Let's check some information about the politeness here. One interesting research, again quite fresh. They're saying that their study showed that if you express joy, and the reporter is you. The reporter is the person who is reporting the changes. So you are coming with the changes and you say, I would like this stuff to be merged, and you express joy and this valence We're going to discuss what it is on the next slide. So you are super positive about that. Then the chances are higher that it will be merged. That's just scientifically proven statistics. And on the other side, on the contrary, if you express sadness, anger, all of that, and if the anger, dominance, whatever, expressed by the comments received by the reporter, the likelihood to be merged is lower. So if you are positive, if you demonstrate to them that this pull request is very important, that you are super positive about the value of this framework, that you need this framework, you're going to get through. I think it's obvious, right? I'm not saying something which you didn't expect me to say, but, you know, science is investigating that. So people from universities and from companies, they're interested about that. Maybe their intuition was the opposite. Sometimes it happens. Sometimes when you start the research, you expect something to be in this way, but then you find out, and we will see the example of that a bit later in this lecture, how people misunderstood the situation. They were expecting this to happen, but after the research, they found out that something else happened. But these guys, I think they went along the intuition. And valence, by the way, because I didn't know this word, so I decided to show it to you too. So the valence is the hedonic tone, whatever it means, which is the positive valence corresponds to the goodness or attractiveness of an object. Negative valence relates to badness or aversions. I hope it helps to you. This explanation of what is the balance. Another interesting study which tells us that, which is quite interesting for me. I didn't expect that. That goes against my intuition. They say that the larger the difference in personality traits between the person who is submitting the request, the pull request, and the person who is closing it, who is deciding to close, accept or reject, whatever, the more positive effect it has on the acceptance rate. So basically, if you are a very assertive and decisive person, the person who makes decisions in a very assertive way and is very direct and very straightforward, and I am a shy person, full of doubts, I don't want to hurt anyone. I don't want to go against anyone. I'm just a peacemaker, a peaceful person. So that would make the acceptance rate between us higher, comparing to the situation where I would also be an assertive person. I'm a direct and assertive person, and you are. Then the acceptance rate will be lower, apparently. Maybe it is this way in other areas of life. You can say that two people who are similar in their personalities, it may be difficult for them to stay together for a long time. Maybe people who are different, they kind of complement each other. They kind of maybe help each other to keep this couple, the pair or whatever. It doesn't need to be a couple, because in open source we don't know anyone. We just don't know who we are. We sometimes don't even know whether we're alive, we're humans or we're robots. But it seems that the social factor plays an interesting role. So when you get into an open source repository and you see the person there who is acting in a way that may be not a comfortable way for you, maybe remember this, that maybe this is the chance to get your pull request accepted, because you are different from him or her or whatever it is, or maybe it's a robot there. We don't know. And very soon we're not going to know that for a fact. Very soon there will be actually robots behaving like humans. there will be computers accepting your pull requests, actually talking to you, not just making a summary, which I will show you also in this lecture, how computers can communicate with you now. Computers powered by ChatGPT. But in a few years, there will be computers talking to you and actually behaving like people. And you're not going to understand who is it. Is it a human being or it's a robot? I see you're asking questions probably related to the previous question. You say, when I want to make a comment of merging, whom I need to tag to make it as quick as possible? It's your question. Like I said, it's better to find a way who it was in previous pull requests. Just go to previous pull requests and see who was the person who merged them. And that is the decision-making person who clicked the merge button. This is the architect. This is the guy who makes decisions. And you talk to him, to her, to that person. Like I said again, we don't know who they are in most cases. So you just talk to that creature, to that entity. And then that entity will decide who to refer you to. In some projects, there are many people who are involved in code review. And it's not necessarily going to be the architect of the project who will review your pull request, but you address your comment to the top guy. You start with the top. You say, I know that you are the person who merged pull requests in this repository, so please help me there. If you know who this repository belongs to which account, then you don't need even to find out. You just know that this account belongs to this Jeffrey guy, so you say, Jeffrey, please merge. And then Jeffrey will say, no, it's not my job. This Mary will do that. And he will say, Mary, please join in, make a code review. And then Mary will review, but most probably in the end, Jeffrey will click the button because Mary will just make a signal to Jeffrey and say, hey, Jeffrey, I did a code review. That's good enough. Let's merge it. But you start from the top. You find the top guy and ask that guy to help you out. And you're saying the same. You're saying that you've seen the situations where the person who is involved in the pull request is not always the main contributor. That's true. Maybe not the main guy, but you don't know this situation, this organizational structure of their team. You don't know who is reporting to who, but you definitely can be sure that if you start talking to the main guy, you will be redirected to the right person. But if you start talking to the low-level guy, to somebody who you think is the decision maker, then you can make a mistake, and that will just lead you to the wrong direction. Start with the main guy. Let me show you another interesting study where they say that they're saying that both technical and social aspects are taken into consideration when they review your pull request. We discussed that in the first lecture. We discussed that people pay attention to who you are. Either you are a young person or a mature person. Either you're a man or a woman. Either you're a robot or a human being. Either you have a long history of contribution on GitHub or you are a newbie. So people do pay attention to that. But now we are saying that it is directly related to the pull request acceptance rate. So they will reject you if they subjectively find you unattractive on some levels. They don't like cats, and there is a cat on your avatar. You increase the chances of being rejected. That's how silly it is. But it is the reality. It's the world we live in. We are humans, at least so far. We're humans, so we treat you, we understand you, we deal with you as we would deal with a human sitting next to us on this chair. So when you submit a pull request to me, I do look at you, I do pay attention. Who are you? And if you have no avatar, if you have no description on your profile, then I get very skeptical about accepting your pull request. Because I see that you didn't invest time, you didn't invest any effort into making yourself representable, into making yourself credible, into making yourself likable. If you didn't invest, why should I like you? Even though the code looks interesting. Even though I believe that the code you write is actually important for us. I still will be subjective. And this is not good. The people who wrote this article, they criticized that. And this is their paper. They actually, in their study, they made a research like that. They used an eye tracking hardware and the software. I think it was maybe only software. I think maybe together. So they gave people a number of pull requests, and they were checking what the programmers are looking at when they decide to merge pull request or to not merge pull request. And you see, this is how the eyes were moving. This is how people move their eyes while they study the GitHub profile. And the avatar matters, you see? So it's a large circle over there, meaning that we move our eyes there. We want to know who you are. I want to know how you look. Not me, everybody. It's a study made on a few dozens of programmers. It's a group of developers of different ages, of different competence level. We want to know, how much did you contribute before? We want to know who you are, how do you look? And then we maybe want something else. We want to see what repositories you were working on. We do pay attention to this information. But the authors of the article, they criticize GitHub for that. They're saying that GitHub is increasing the size of avatar images and emphasizing the developer's personal brand by spotlighting features such as contribution heat map. So GitHub is actually doing that. The GitHub is making avatar bigger, is placing this heat map on the first page, so it just helps people to represent themselves. And they're saying, in the future, look, this is the criticism coming. In the future, platform designers, who are GitHub makers, must be more mindful in balancing the power of signals that can amplify bias or harm against users. So they're saying, don't do that. They send a message to GitHub from their research paper, which was published 3 years ago, 4 years ago. So they don't like it. They don't like it, but that's the reality. You may also not like it. I may also not like it, but that's human beings. We are human so far. We're not robots. So I cannot just objectively look at your source code. I do want to know who you are, who is staying behind this change. And if that person doesn't have an avatar, I will be more critical. I will be more skeptical about your changes. Maybe you're a robot. Maybe it's a random change. Maybe you made it and that's your first pull request and the last one. You're going to walk away from this platform and never come back. So why should I care then? Why should I be interested in helping you? Like I said, it's a situation of teacher-student. I'm kind of teaching you, I'm kind of helping you to make the code better, and I'm trying you to learn something. But if you don't care about yourself, you don't even put your face in there, then I shouldn't care as well. Again, maybe it's not good. Maybe this is not how the world should be organized, but this is how it is organized. I'm seeing your question, one more. Let me read it. What are the best words to skip robot and then talk with the right person? Or robot for pull request could analyze all by its own and apply my changes using static analysis. To my knowledge, we don't have robots right now which would apply your changes immediately. Let's review them and make a decision to merge your changes. We're not there yet. We don't have any, maybe somewhere, but I don't see these robots in public, and I would be very skeptical of using these robots. If somebody would tell me that, hey, connect this robot to your repository, the robot will review the changes and then make a decision and merge those changes. That would be super difficult. Well, I have one robot on my own, which I created last year. The robot which is looking for contributions made by robots. You know, there is a robot on GitHub which is called Renovate. I suggest you to use it, Renovate, which will just look at your repository, find the versions of dependencies which are lower than the maximum available right now, and submit pull requests trying to increase the version of the dependency. And then it's your job to merge or not to merge this pull request. But I have hundreds of, not hundreds, but at least 100 of repositories in my GitHub account which are alive, which have the code which is supposed to be working, and most of them the code works. And so you can imagine how many pull requests is coming, how many are coming from this Renovate bot. At least 20 I get every day. 20 every day. Of course, I cannot review them myself. Well, I tried in the beginning, but then I created a bot. It's in my GitHub account. It's called Mergem. That's the name of the repository, which is short for merge them. So this Mergem bot is being activated every hour, and it goes to all my repositories and it checks all pull requests which are coming from this bot. And if it's coming from this bot, then Mergem is sending a signal to another bot, which I also created, which is called Rulter. And this Rulter just merges together. So that's an orchestration of 3 bots, but you can imagine how simple they are. They are not checking what the changes are. And of course, the GitHub Actions is also involved. GitHub Actions also are involved. So there's 4 bots, 4 computing systems, 4 automated systems which contribute to my repositories, and it works quite well for, I think, for a year or something. So I get, in my repositories, I get merged maybe 20, sometimes 50 pull requests every day. These systems, they do it. I don't touch that. I cannot do that. But again, like I'm saying, it's a completely routine, very predictable, easy to understand changes. They just increase the versions of the dependencies. The increase is coming, pull request is coming, GitHub Actions check whether it's okay. If it's okay, then my bot comes in, the Mergem bot comes in and says, okay, the CI is clean. GitHub Actions says everything is good. The changes, they're coming from Renovate bot, so nobody can do it. So there's no harm can be done because I trust this Renovate bot. And then I send the signal to Rulter and I say, and not me, the Mergem bot sends the signal to Rulter and says, Rulter, please merge. And it gets merged. Maybe in the future, there will be systems, there will be robots who will not only look for pull requests from the Renovate bot, but for all pull requests coming from you, coming from outside contributors. And these robots will make decisions like this pull request is quite primitive, quite simple, easy to understand what's inside, so let's just merge it. Not maybe, for sure, they will exist, but how much time more we need to wait for them, I don't know. Next recommendation, be a leader and the boss of a pull request. Maybe I'm repeating myself here a little bit again, but this recommendation is again reiterating what I said before. You're the leader, you're the boss, it's your responsibility to get your pull request merged. I can make you another reference to a study where they found out that the level of your prior interaction on the project, how much you interacted with the project, affect the politeness of reviewers. So the more changes you make, the longer you stayed with the repository, the more contribution you make to them, the more politely they will talk to you. I think it's also only confirmed the intuition. I believe it's an obvious fact that the longer you give them something, the better response, the higher amount, the bigger amount of politeness, the bigger amount of appreciation they will give you back. So if you want to be appreciated, stay in one or a few repositories where the same group of programmers work. They will understand who you are, make your profile interesting, make your profile beautiful, put the avatar there, put the description who you are, and stay with the same group of people. They will appreciate you more and more and more, and you will grow as an open source contributor. Next recommendation, number 5. I think we have 7 in total, or something like that. When you submit a pull request, you have to explain or make a description of a pull request. This is something that most programmers don't know how to do, or just too lazy to do, or too busy to do. They just make a pull request, say a few words there, like I fixed the bug, I did what you were asking me for, and that's it. This is not good. This is not the right approach. You have to try to invest your time into explaining what kind of changes you do. And the most important part is to explain why you made these changes. Not so much to say what you did, but tell us why you do the changes. This is way more important, the why part, comparing to the what part. Because what you did, I can see from the code. More or less, I will see what you see. More or less, I will understand what you did, especially if your pull request is small, especially when you didn't put too many changes in there, but only made one change. Then I need to know why you make these changes. Either you're fixing the bug, or you're improving the code base, or you're trying to suggest something, or you're trying to demonstrate the defect which we didn't see before. Tell us why this pull request is coming. And let me show you some interesting research which analyzed a huge amount of pull requests, 300,000 pull requests, and they split them into different categories. Take a look. Empty description pull requests, 30% of them, they had no description. That's a terrible situation. 1 out of 3 pull requests tells us nothing about what's going on. Trivial description pull request, how much is it? 60,000. So it's what, like, how much? It's like 5%, right? No, sorry. What am I saying? It's 2%. Long description pull request, that's like 0.7%. PR with only 1 commit. That's interesting, this pull request with only 1 commit and pull request with more than 20 commits. And long source pull request, so the pull request with the big amount of changes. And finally, adequate pull requests. So the pull requests which do not belong to these categories, so they look normal according to the classification of these people who made it a few years ago. So it's only 1.3% of pull requests actually, what am I saying? It's not 1.3, it's 13%. Sorry, I'm totally lost here. So this is not 2%, this is 20%. This is, yeah, that's correct. And it's not 0.7, it's 7%. Sorry. So there's like 13% of pull requests actually look okay. We're not talking here about their content, about the semantic of them, so exactly what they did. We're talking about their presentation, about their description, about the way they're made, the way they're formatted. And only 13% actually look okay. If you will belong to this group, if you will be here, you will be successful. If your pull requests will be properly described, if you will explain why you're making this pull request, with the proper references if necessary to the right sources, with the proper references to code places where you explain what was wrong, with the proper references to other pull requests, to previous pull requests, like write a story there. Like a short story, write a short story in which you tell us what's going on, in which you tell us why did you start working on that, what are you trying to achieve, and then here's the code. I can see the code without your help. Your job is to tell us the story of why. And let me show you an interesting example of a software which right now can actually tell us what you did. Remember, I told you, don't write to me what you did. Write to me why you did it. Why? Because what you did, I can automate. I use this software, we use this software in multiple repositories which we work with, in our repositories. This is ChatGPT based software. You can connect it to your repository as well, and it's completely free for now. It's quite fresh, it's maybe 1 year old. It's made by a company which I don't know, but they made it public, they made it free, so you just connect this PR codex to your repository, and this is how your pull request will look like. This pull request, we merged it just last week. It's just just now happened. So look what happens. This is my pull request. So I submitted this pull request. I provided zero explanation of what's going on there. Zero. So I'm not a disciplined contributor. And this PR Codex automatically understood what's there and created this description for the pull request. So the text you see here was not written by me. It was automatically injected there by the robot. The moment I submit pull request, the robot gets a notification from GitHub server. The robot goes into the pull request, reads the code, sends it to the ChatGPT. ChatGPT generates this summary, and boom, you get the summary. It says, you corrected some spelling error, you updated the comment, you added something, you updated, you improved. This is what you did. It's quite convenient. We use it for a year already. And we pay attention to that. When the reviewer is getting the pull request, the reviewer pays attention to what's said there because it's easier. Because if you look at the code is pretty large. Look, files changed, 26 files changed. It's a big contribution, quite big. I don't see how many lines changed here. I don't have this number here. But you can imagine that this change was not a micro change. It was not just a few lines of code. That was 100 or maybe more. And of course, it's very convenient to get this summary, especially if it's free, and especially if you can connect it to any repository of yours. So my recommendation is to do that. This is how you get a description of a comment. But this software cannot tell you why. This software doesn't explain to me why this pull request is coming. It's just a summary of what was done. And you see, the focus of this pull request is to make changes to the code diff in order to correct spelling errors and improve code readability. This is sort of a why. This ChatGPT is trying to answer on the why question, but it failed because this is not true. So this description is wrong. What is said here is far away from the reality. It's not completely wrong, but it doesn't help. It would be way more helpful for the reviewer and for the project in general to know why the change was made. And it's very important for the traceability. You know what is traceability? Traceability is the ability to later understand why the changes were made, who made them, when they were made, what kind of changes were made, and why. So I ideally want to go back in all the pull requests and see how people were contributing and why they were doing this. This is very helpful for many activities in the future, for rolling back the changes, for understanding mistakes, because people make mistakes, and at some point of time we want to roll back and we want to go back in time and see who introduced the bug and why. And maybe it was not a bug, maybe it was an intentional change, which now seems to be a bug. In order to give me this information, in order to help me in the future, you give me now the explanation of your changes. Let me read your question. Is GitHub the most suitable platform for open source projects? What are its analogies and how are they better? Or GitHub is the undisputed leader in this field. It is undisputed leader in the field. It is. Fortunately or unfortunately, hard to say. But GitHub is the monopoly, is the one place to go. There is no other options so far. Well, they exist, but it's incomparable. You can't even discuss that, in my opinion. Is it possible to change? What do we need to do to change that? That's an interesting question for future debates, for future conversations. But so far, just don't bother, don't waste your time on any other platforms. Just focus on GitHub. Maybe geopolitical problems will eventually make it impossible for some people in some countries to work with GitHub. Right now it is already. GitHub is already blocking people from Iran, for example. And they're blocking people from Crimea. So if you live in Crimea and GitHub will understand that your IP address isn't from Crimea, then your account will be blocked. And it's already 10 years like this. But these territories are not huge. Maybe the size of these sanctioned territories will be enlarged in the future. I hope it's not going to happen, but who knows? Maybe in that case, some alternatives will show up on the market and we will be able to seriously consider them as alternatives. Right now, we can't do that. All the alternatives, they're just incomparable. Next recommendation, be prepared for criticism about your style, not functionality. That's an interesting point which I didn't know before I started to prepare for this lecture. Apparently, people when they review your pull requests, they pay more attention to how your code looks instead of how your code works. And that's reasonable. Now I understand it's reasonable and I can explain why. It's at least my position. I also do the same. I also will look at how you write your code instead of what it does. What's the functionality? Because I trust my continuous integration. Because I trust my unit tests. So your code is coming and I know that if you break something, the CI, the GitHub actions, they will catch you. Because I wrote unit tests before. And that's why I don't need to validate whether the functionality is okay. I mostly check how beautiful is your code. Because like I said, it's going to be my code when I merge it. It's going to be my repository. It's going to be code written by me, because in a year I will forget you, I will forget your contribution, I will forget all the pull requests. I will remember the code which is in front of you. It's going to be my code. I will completely forget who helped me to develop that. It's going to be my part, my piece of work. So that's why I want it to look the way I want it to look. I want it to look like I wrote it. I want it to look my way. So I pay attention to the style. And that's some science proves that. Look at this. Only 15% of comments provided by reviewers indicate a possible defect, and much less a blocking defect. Rather, the feedback is related to code maintainability, which is style. Maintainability is all about how the code looks, not how it works. So it's at least 50% of all comments, they're related to maintainability. So, a little trick for you. When you make a contribution, you students, you must understand it better than me. That's how you do it on exams, that's how you do it on diploma work, on everything. You just make some mistakes intentionally. The mistakes which are easy to catch. You just submit a pull request, make it look not perfect, make it look unmaintainable, and expect the reviewer to pay attention to them. And they will. And then you fix them, and your code goes in. Maybe it's not really fair, maybe I shouldn't give these recommendations, but it most probably will work because we know the numbers, because we know that people pay attention to the style of your code. They pay attention to how it looks, not how it works. So play this trick and you're going to get merged more effectively. Look at these numbers. Again, just recent study. Unexpectedly they say, quality flaws measured by PMD turn out not to affect the acceptance of a pull request at all. PMD is about style. PMD is a Java style checker. So they are saying that actually they're saying something which is even worse than what we just heard. So we just heard from the previous page, from the previous research, that people don't care about the functionality. They care about how well is your code formatted. But now they're saying that people even don't care about that. People care about your reputation and the importance of the change. So even if your code doesn't work, even if your code is wrongly formatted, you have quality issues, we pay attention to who you are, to who is the request coming from, which is good, bad, I don't know. We just discussed, that's the reality. So, but here I may say that my position, I would say that I would also not pay attention to these quality flaws measured by the PMD. Why? If you, for example, submit a pull request to my repository, which is written in Java, and inside your code there will be style errors, It will be not perfectly formatted, and PMD will complain. I'm not going to complain to you because PMD is part of the build for me. It's part of the continuous integration setup. It's part of GitHub Actions. So I know that together with the PMD problems, the code cannot be merged into repository technically. So I cannot click, well, I can, but I will not. My system, the Rulter, which I told you about, Rulter, the system, the robot, Rulter, this system is not going to merge your code because there will be an error, the PMD error, and the code will be rejected. The pull request will be technically rejected. So for me, it's not necessary to waste my time on explaining to you that your code is not properly formatted. Please pay attention to the extra space which you put in there, to the wrong indentation which you use there, to the wrong name of the variable which you use, which is against my quality standards. I'm not going to say anything of that to you. I will just say, okay, thanks for the contribution. I like your code. Let's try to merge. And I will click the merge. I will give the instruction to Rulter and say, please merge. And the Rulter will tell you, I can't merge because you made a mistake. And then it's going to be your problem how to fix this style and come back to me. And then I will ask Rulter again. I think it's a reasonable approach. So maybe this is what this paper is saying, but I think not. I think in most projects, this PMD is not as strict as in our projects, and people just waste time telling these contributors, telling these requesters of how the code should look. I don't do that. And you shouldn't do that also, I believe. Configure GitHub Actions the way that GitHub Actions can push away all the people who try to damage the maintainability of your code. Make PMD and GitHub Actions the protectors, the defenders of your code, of the quality of your code. Final recommendation, which is the most interesting in my opinion, which is the most opinionated, which is something that you may probably disagree with. Not only you, but I actually wrote the blog post about it a few years ago, and I got many negative responses, many negative opinions about that. People disagree, but I still will insist. I think that it is a good practice to commit the changes in 2 steps, in 2 pull requests. In the first pull request, you commit the unit test, where you prove that the second pull request is necessary. And then you commit the second pull request. Let me give you an example. 2 pull requests, one on the left, one on the right. Take a look at the left one. Let's say I have a Fibonacci function, which calculates Fibonacci. This is Rust programming language. Let's say I have a Fibonacci function, which doesn't calculate anything. It returns 0. So it's a bug there. The function doesn't work as expected. What do? I may make a pull request and implement the function, fix the bug, make it work, and it will calculate Fibonacci number in one pull request together with the unit test. So I will commit the unit test for this function and the implementation of the function. I don't do that. Instead, first I commit the pull request, the unit test. I make the unit test and I make it disabled. In the pull request, I say, in the unit test, I say, call the Fibonacci function and make sure it returns the right number. I send this pull request to the team and I say, please merge it. The question is why? I say, because there is no unit test for this function, and I believe there should be one. There should be a unit test which checks the functionality, but I cannot make it work, this unit test, because your function is broken. So I give you the unit test, I invest my time into creating the unit test, and I disable it. If tomorrow you will decide to fix your function, enable the unit test and make a fix for the function. So my contribution is the testing, is improvement of the testing system. The team will gladly accept it. They will say, oh, that seems like a reasonable unit test. They will read this unit test. They will say, yeah, it looks like this is how the function should work. That's a reasonable contribution. And you can also put this marker on top of the pull request. Explain that please make it in the future to do. You explain that this test doesn't work. You say fix it. We discussed this approach before. It's called puzzle-driven development. So you basically put this puzzle into the code and it goes into the repository. You merge it there. And you get money. Remember, we're gonna get paid for each pull request. That's the mentality you should have. You make a pull request, you get the money. Another pull request, another money. And here comes the second pull request. You delete the marker, you delete the ignore annotation on the test, and you implement the code. Of course, this implementation is not perfect. Actually, it's a dumb implementation. It's a wrong implementation, but the unit test will be happy. And this implementation is good enough for the unit test. On the second round, you may say, okay, you look at this code and you create another pull request and you say, I suggest a new unit test because apparently this unit test is not strong enough for this function because look how silly is the implementation. Most probably because the unit test is not perfect. So you make another pull request, you make another unit test. And in this unit test, you introduce a better system for testing of this function. And then when you fix the function, you submit another pull request. So basically, a test and the fix, they should go separate. And if they go separate, it makes it better for the code reviewer. When I get your test in a unit test, I know that you're not changing my code, you're not changing the functionality, you only introduce the test. And it's safe for me. It's okay to have an extra unit test for the functionality. It's perfectly safe change. I can merge it, no problem. You make a better test, you make a stronger test, you make it disabled, you make it ignored. It's still okay. You don't damage me anyhow. I don't see the risk there because you only increase the amount of tests. You don't only increase the power of the test framework around my code. That's okay. Next step, you submit me a fix. I see that you don't change the tests, you only change the functionality, which is also a safe operation. If you don't touch the tests and you change the functionality, I know that your functionality changes are made in order to satisfy the test, or it already satisfies the test. And when you do the removal of the ignore annotation there, I know that, that you are adding the functionality just to satisfy these tests. You don't break anything. When you're coming to me with the test and the functionality in the same pull request, I don't know whether you make a break or not, because you introduce a change and you change the pull request, the unit tests together with the changes in the functionality. So maybe you break something, and because you break something, you change the unit tests. So it may be some kind of cheating or maybe just a mistake coming from you, which many programmers make. They just open the functionality, they make some changes there, they see that the tests are not working, and they fix the tests as well. And that's how they break the code, because the tests are supposed to be the indicators of your mistakes. But if you make a mistake and at the same time fix the indicator, you basically shut up the unit test, you just silence the unit test. And they're coming together with me. I don't know whether you silence the unit test by mistake or because you're cheating, or it was really necessary. When you separate these two steps, it's way easier for me to understand what's going on. So that's my general recommendation. Do it this way. Change is coming separately from a unit test. Read the blog post. It explains it in a little bit more details. And I think it's pretty important practice or philosophy even of development. And it increases the number of pull requests. Remember, we want more pull requests. We want more. We want to increase the number of pull requests. Actually, the number of pull requests coming from you, which are merged in the repository, may be the primary metric of your productivity, which you can report to your boss and get your salary attached to this metric. That's my understanding of how to measure the performance or productivity of programmers. So if you join my team, then I will measure how many pull requests you merge per month. And if you merge more, I will be ready to give you a salary raise. And I believe this is the right way of measuring productivity of programmers. If you are a programmer, you have to either report bugs or make pull requests, or both. If you can't do any of that, then you're just lazy. In order to increase the number of pull requests, how you do that? That's one of the methods. Just make tests first and fix second. I see you're asking the question, does continuous integration help to catch all possible backdoors? How can I secure the reliability of the injected code besides self-inspection of the pull request? Well, there are basically two mechanisms of checking the code which is coming to you. The first mechanism is automated checks, like you said, CI/CD. Robots. The robots must check your pull requests coming to your repository from all the different sources. Robots. The stronger the robots are, the better for you. The more robots you implement, the better. The more checks you install there, the better. There are many tools right now on the market which will allow to check different aspects of your code, the style of the code, the formatting of the code. You can make unit tests there. You can make automated tests. You can make UI tests. Invest your time into automation of tests, automation of quality control. The more time you invest there, the safer you are, the higher the quality of your product. That's first instrument. The second instrument is code review. The code review is something we're going to discuss on the next lecture, how to do code review. When you submit the pull request, you get an answer from the robots, an answer from these machines who check your code, and you get an answer from people. Maybe from one person, maybe from a group of people. They check your code and tell you what it is. That's it. How you can catch the backdoors, how you can catch some injections which may be coming from outside contributors, manually or by the machine. And apply the principle, the smaller the pull request, the higher the chance of being accepted. Demand your contributors to make small pull requests. Ask them to come to you with smaller changes and never compose the changes into one pull request. That's the recipe. That's all we can do. There is no silver bullet. There is no guarantee that your repository will never get code, the bad code from outside. You will. If the repository is popular, if you're getting 2, 3, 5, 10 pull requests every day, how can you control the quality? Only either by robots, by machines, by checkers, or by pull requests, by code reviews. Another question from you. Where do repository owners describe all the rules for PR? Well, sometimes they describe, but I believe these rules have no value, in my opinion. That's why I didn't mention that to you. I don't think you need to either pay attention to these rules, to be honest, and you need to spend time on describing the rules. Just let the people freely contribute. They will make pull requests the way they know how to do it. And your job is to review what they make and suggest them to not make something that hurts you as a code owner, as a maintainer of the repository. But rules, they don't help. People don't read rules. People don't read instructions. People don't read guidelines. No. People listen to rejections. People listen to the punishment you make to them as a code reviewer or as a contributor. Because if you don't contribute to repository, or if you contribute and then don't continue the contribution, this is the way of punishment you make for the owner of the repository. Because the owner didn't do the code review properly, which we're going to discuss next lecture. So people listen to actions, not to texts, not to suggestions, recommendations. People ignore that. Only to actions. You reject, that's what they listen. You accept, that's what they understand. And same to you. Be pushy, be assertive, be direct, try to make your code get in, and count your responsibility by the amount of pull requests you managed to merge. This is your primary indicator of productivity. In open source, not in open source, anywhere. How many pull requests you merged last month? All of you. Just give me the number. 5, 1, 0, 50? How many? How many pull requests? This is your productivity. This is your value as a programmer. Not the amount of books you read, not the amount of code you write, not the amount of lectures you listen to, not the amount of money you got from your employer. The amount of pull requests which got merged. This is the primary indicator. That's it. Enough for this lecture. Thanks for listening. Next time we're going to talk about how to do code review, how to not accept pull requests which are not good, and at the same time how to accept what is good.